All right. Hello? All right, so it is 8:30, so we'll go ahead and get started. Just a reminder that in this room is going to be the study union session, so the final exam review for Statistical Methods I. Before we get started, I would like to mention that I specifically was assigned to Dr. Jarashek's section 1. So if you're here from other sections of statistical methods, there may be some discrepancies, maybe things that your professor included that this professor did not, or perhaps things that she included that you did not go over in your stats class. As always, please refer back to your professor's lecture and what your text says. Do not be alarmed if you perhaps see things that you haven't seen before and you have one of the other professors. It's possible, just make sure you check back in your own notes. If you've checked the Study Union website for materials for this session, you will have noticed that there was simply a topic guide that sort of pointed out all the sort of things that you should have looked over before coming here. And I will be giving about 37 questions of a practice test, so we'll see where you guys stand. For Dr. Jurasek's students, you have another week to sort of review wherever you leave off at this test. Others of you might be a little closer, so this will give you an idea of how prepared you've been when you've been studying over these last couple weeks. Near the end of session, I'll put up where this problem set and an accompanying key will be posted on a separate site. So I'll make sure to put that up later. I would like to mention, I have this disclaimer at the top of all my documents. I don't see your final, any of the stats finals. I have no way of knowing exactly what's on your exam. So there's no guarantee that this will cover every single thing on your exam. And there might be things on here that you don't end up being tested on. That's perfectly normal. If there are any errors, please try and bring them to my attention. Feel free if you notice them. Again, I'm not your professor. And make sure you study the rest of your lecture notes, your textbook, and you go through the problems assigned. All right, so with that, what I'll do is I'll display a question. I'll give you a certain amount of time to work on it. Feel free to talk to your neighbors, consult your notes, whatever you choose. Just try and be a little quiet, be considerate, and then we'll discuss it. If ever it gets cut off or blurry on this, let me know, or if you can't hear me. Okay, so one of the first topics you may remember from way back at the beginning of the semester was categorizing your data, figuring out what type of data you're working with. So here you have a scenario where a young man is sitting by the pond and he's counting the ducks he sees. And he's also looking not just at the number of ducks, but also at their feather color. So what are the types of data he's collecting? What did you guys find? So I heard C, so quantitative for the counting and qualitative for their color. So you can think of, your counting variables when you're actually taking measurements. He's getting these tangible numbers versus qualitative, you think of quality. Quantitative, it sounds like quantity. So a lot of these words you can sort of break down in that manner. Oh, for this review, you will probably need a calculator, as you noticed, and eventually it will be a good idea to have your probability tables out, given by your professor, if your professor distributed them. Question?
Are you posting this online after this session is done?
Yeah.
All right, perfect. Thank you.
I'll put that link up under the doc cam near the end.
Thanks so much.
Also a reminder, if you didn't hear the announcement earlier, that the session, aside from being streamed live, will be posted on YouTube on the SARC channel, so you can go back and also watch it, if you please. Okay, so what did we find for this question? So I heard D, so 0.32. So can anyone say how we got to the number 0.32? So feel free to raise your hand and then speak up. So go ahead. So what he said, so I can repeat it, so everyone can hear it, and so the people watching the stream can. What your classmates said was you take the number of sophomores, so 69, and you divide it by the total number of students for all 4 classes. And that should give you 0.32. Thank you very much for that. So the important word here, by the way, is relative class frequency. So keep that in mind. What would the answer be if I just asked for the class frequency? What would it be if I just asked for the class frequency? BA, so 69. So then you're just counting the frequency. All right, so in this one, we're asking about skew, specifically a positively skewed distribution and whether that is the same as a left or right, and how the mean relates to the median. So what answer option did you guys find? So I heard B. Why B? It's all right to be wrong here. I mean, we're reviewing. This is the time to make the mistakes so they're not on the test. So we're all here to learn. So I heard E. Why? So I'm hearing a couple different answers, so let's break it down. So with a positive skew, does the tail go more to the right or to the left? So you said the tail's on the left? How do you guys know? Does everyone agree with that? Like I said, you guys can reference your notes. Like if you want to pull up things from lecture or from your book that had pictures of these graphs. I will say that this is a question that tends to stump students a lot. They tend to get it flip-flopped and reversed. So it seems like maybe this is a question that, I mean, has anyone figured it out?
Is it A?
So explain why it would be A. So a skewed right. So that could be A, B, or C. So when it's positive, the mean moves to the right? That's what you're saying? So then it would look something like this, where the mean would be more this way, and the median would be more the other way. So our mean is greater than our median. So when we look and we see all these positive values, because what is the mean? How do you find the mean? Yeah, sorry about that. How do you find the mean? What's another word for the mean? So the average. So if I threw in a bunch of, or a couple of high numbers, would that pull the mean down or up? So up. So whereas it looks like the median sort of just stays with where that peak is in the graph. So with the positive right, so when you look at usually graphically, the more right you go, the higher you go, the more positive you go. So it goes hand in hand with right and positive. And then just understanding what that means for the data. So that if you see a similar question on the test that asks you about the skew, or even if you're just looking at the graph, you can sort of make sense of why we can use all these qualifications interchangeably. Does anyone still have any questions on skew? So this is, I think, maybe something to look over. Because again, it's something from the very, very beginning. Okay, so with this one we were looking at a distribution of heights for adolescents, and we noticed that it's normally distributed, and we asked, so what proportion of adolescents will be between 2 standard deviations below and 2 standard deviations above? So all semester long you've been sort of drawing graphs. So below the mean height and above the mean height. So we want to know the proportion that's right in here. What did you guys find? So I heard B, and I heard D. Which is it? D. So I sort of mixed in the answer choices here from 2 different rules. So what are the 2 rules that we look at that tell us about the approximate proportions that are found between different standard deviations. Heard someone say Chebyshev's. What's the other one? Empirical. So when can we use Chebyshev's rule? So anytime. What about the empirical rule? So we are looking for a normal distribution. So in here we can see back in the problem we said normal. So what does the empirical rule tell us for plus or minus 2 standard deviations? How much does it say lies in that range? So approximately 95. Which one would be the Chebyshev's option? So at least 75. And notice there's a little bit of a different wording there. How we mentioned there's approximately when you're using empirical, and then there's the word at least with Chebyshev. So if you look at it, technically 95% is at least 75%. So Chebyshev's isn't wrong. But we can see we can always use Chebyshev's, but empirical, we choose to do it when it's normal. So we're looking for more of an about approximation versus a wide range. Chebyshev's, it could be anywhere above 75 to 100%. It's a very wide range. Okay, so for this question, you were asked to calculate a z-score. So we were given the mean length, the standard deviation, and then a point of 19 centimeters. So my first question is the z-score positive or negative? Why is it negative? So it's less than the mean, so it's negative. Always check the signs. So what's the answer? So B, so negative 1.07. So we said it had to be one of the first two because of the negative. So what was the formula to find a z-score for this? What formula did you guys use? So I heard x bar minus mu over sigma, and someone said that that equals a z that we're finding. So what's our x bar in this case? So that's 19. What's mu? What does mu represent? 22, which you mentioned was the average or the mean. And then what was sigma? So 2.8, so the standard deviation. That's another thing. Keep track of your variables. That's one thing that could trip you up, knowing the differences between the different variables, knowing sample versus population. Is mu the population or sample mean? So her population. So what's the symbol for the the sample mean, x bar. So I can see your classmate said x and then I wrote x bar. So it's a little similar to an equation we'll look at later. So. So now we're moving on to probability, which is the topic that tends to give a lot of students a lot of trouble. So here we were talking about at a snack bar, 50% are going to order a drink, 35% choose to order a snack, and 15% will order both. And I asked for 2 different probabilities. I asked for the probability of only a drink, and the probability of the union. What's the symbol for union? So I see someone drawing a U. So what would intersection look like? So someone drawing like the end, so the other way. Looks sort of like an and, like an N. So what does it mean, union? What's the definition of a union in terms of probability? Go ahead.
Probability of A, probability of B minus the probability of A and L.
So there's a formula. So your classmate was saying that it was the probability of A plus the probability of B minus probability of the intersection. In words, though, how would you describe the union? If I didn't say calculate the union, what's another way I could ask you to find it? So you said the probability of getting both? So I hear a lot of or. So one or the other or both. And then what's intersection? So the word and. So that's why I mentioned it looks like an N, like in the middle of and. So it's both of them. So A and B. So we looked at how to solve for union. And so what answered option did you guys find? Like I said, it's okay to be wrong in here. So why would it be A? So if we check that with the math though that we talked about with union, would we still get 1? If you did the math. Yes, or? So now I hear C. So we can go ahead and do the math together for a second. So we can call A just the first probability we see. So we can call it just probability of drink. So we have 0.5 plus probability, our other probability, which we could do the snack. And then minus the intersection, which we said was the both. So minus 0.15. And when we do that, you should get 0.7. So we look and C is the only answer option that has 0.7. Can anyone tell me why the first part, the probability of just ordering a drink, is 0.35 and not 0.5? So I heard you have to subtract the people who ordered both. So this just says who ordered a drink in total, not just only a drink. So if it said only a drink, then we would go, okay, that matches off with the wording we were asked for. So here we did 0.5 minus 0.15, which would give you 0.35. So always think about it and read the question very thoroughly. Read how it's phrased. So another probability question. Okay, so for this question, we were talking about a group of high school students, and 55% of them said they did well on their last test, and 35% had both done well on their test and eaten breakfast that morning. Given that a student did well on their test, you were asked to find what the probability is that they also ate breakfast that morning. So what type of problem is this? What specific type of probability are we dealing with? So I heard given. So what does that word given tell us? So when we see the word given, we're dealing with specific type of probability. So I heard conditional. So there is a sort of condition that they give us. Which is why we say we're given. So we were given that they did well. And we want to know that they also ate breakfast that morning. What does the formula for conditional probability look like? So probability of A, line B. And what is that equal to? So the probability of A and B over the probability of B. So in this case, what do we plug in for the top? For the intersection up here. So 0.35. So we saw that had done well and eaten breakfast. So this 35 number. What's on the bottom? So I heard 0.55. So what answer did you get from this? When you solve this out? So I heard D, so 0.64. So here we just have a probability rule, probability formula that has to do with, you just had to be able to identify that you were working with a conditional by what was asked of you in the problem when they said that word given, and then look back and see, okay, how do I solve this? And then looking, well, I have a formula. I need the intersection. They gave that to me. I need one of the probabilities. They gave it to me. So you were able to find the probability of one given the other. Okay, so what type of problem is this? So, sorry, you have to speak up a little bit. So, combination, why is it a combination? So, which one you pay attention to order, and which one do you pay attention, you don't care about order? So, which one do you care about order? Which one? So, I'm hearing a bit of both, combination and permutation. Which is which? So, here, someone pointed out that we're talking about a specific order. And if we're choosing out of a group in a specific order, which one do we want? Okay. So I'm hearing both. Does anyone want to grab their notes? So I'm hearing a lot more permutation. So what does that formula look like? I know there's also a way to plug it into your calculator, but for those of us who are using scientific, or maybe haven't figured out the permutation combination function on the calculator, what's the written formula for it? Are you raising your hand? Go ahead, just make sure you speak up. So is the factorial like on the outside of a parenthesis? Okay. we're choosing little n from big N. So what's our big N for this problem? So our big N equals 25, and that leaves our little n as 8. So what number did you guys find? I am sorry if some of you have maybe older scientific calculators and you just got a big error message. My apologies. Or if you just have it in factorial form. About 1 million? So we would have 25 factorial over 25 minus 8, so 17 factorial. So just going to double check on my calculator because I solved it out earlier. So I'm getting a little bit of a bigger number. Did anyone else get a different number? So here's some people saying D. So if the other little n is on the bottom, are we dealing with a combination or a permutation? So that's the one thing, is the combination permutation formulas are very similar. Before we said we were looking at a permutation because of the order. So the combination formula, brought up a good point, has another factor in our denominator, which it would make sense. It would start to reduce down that number if we divide it by another 8 factorial. So about 44 million. So that's what I got, and then I calculated it out about 3 or 4 times. So yeah. So that's why it's really important to know right off the bat, are you dealing with combination permutation? Because, I mean, this number is literally 44 times larger. Sorry, I thought someone had a question, but I think that was outside the room. So that's permutation? So were we talking about a permutation or a combination? So, okay, so I see some people are still confused. So does anyone have their lecture notes or like slides, if your professor does slides, and have it written in their notes which one does order and which one has no regard for order? Okay? So permutation. So in this case, we were doing a specific order. So this is the permutation formula. So, like I said, this will trip you up. And they are vastly different number choices. so now you've had a moment to work this one out. So we're looking at a shipping company which is sending a total of 12 items across 3 shipments. And the number of items in each of those 3 shipments is 3, 4, and 5. So the question is asking how many different ways we can build up these shipments. We can divide them into those specific groupings. What type of problem, right off the bat, is this problem? Feel free to speak up, just hard for me to hear you up here. So I heard combination and I heard partition. So before we were talking about combinations and permutations, we were talking about sort of just pulling out persons and pulling them into a group, and we didn't really care about order for combinations. So here we're placing a certain amount of items in a certain number of groups with a certain number in each group. So is that a combination or a partition? So partition. So with partitions, we're looking at placing people into certain sizes of groups. What does the partitions formula look like? So n1 factorial. So for this problem, how many little n's do we have? So we're doing 3 groups with these number in each group. So how many little n's on the bottom are there? 3. So n2 and n3. What do we plug in for big N? 12. What's our first n? What's one of our n's? What's our next n?
4.
And so that would leave 5. What does the 3 up here mean? So how many little factors we have down here? What is the variable we use to, in the definition we use to represent this number? What variable do we use? So that's maybe something to look over. So, okay. So this last one, we did n1, n2, n3. So n to the k, n to the 1 to n to the k. So did anyone get an approximate number for this one? So I heard D. When I ran this a couple times, this is also the one I got. Did anyone else get anything wildly different? You may be different by something in like the ones place or the decimal, perhaps, but just approximately 27,720. If you got something wildly off, let me know. In the back, and make sure you speak up. How do you put that in the calculator? Okay. This one, I just did it as, well, you can always just solve for the denominator first and get all these terms and do 12 factorial divided by your denominator. I don't particularly know if there's a partitions function on the calculator. I don't think I've used it. I don't know if there's a similar like NPR, NCR function for partitions, but that's why it's important to understand the formula. So there should be, if you have anything more than like a baby calculator, like a scientific or up, should have a factorial key for you. Does that answer your question? Make sure you watch your parentheses in this though. So now we're going to jump into the different distributions with discrete and continuous variables. We're going to move out of probability, which might be a relief to some of you. All right, so this is more of a conceptual question than asking you guys to do any calculations just yet. Just to see if you're familiar with the different types of distributions and when to use them. So a researcher is studying how often a beekeeper is stung by a bee in a given year. What type of distribution out of the 5 answer choices you're given would you use to solve a problem? Like if I asked about the mean or the standard deviation or probability. So I heard, would you say B or D? D, so the Poisson. So, can anyone explain why it's the Poisson distribution? No, you disagree? So it's just looking at the rates that, like, if you had a sample of like 100 beekeepers and you asked them how many times were you stung this year, each one of them, and you would be looking at the distribution of how many times a beekeeper would be stung each year. Like you could have 5 beekeepers and one of them was stung 50 times, one of them was stung 60 times over a given year. So what's the sort of key phrase for this that tells you it's Poisson instead of like binomial? So what's like very specific about Poisson? So the time period, so in a given year. And again, we're talking about how often. So like the number of bee stings, some sort of frequency. So we're doing a frequency over a time period. I think sort of like a colloquial way to remember Poisson, because it is sort of the weird one out of these distributions, is like a Poisson is a fish. It's actually, the translation is like a fish distribution. And you can think about it as if you were counting the amount of fish that you caught when you went out fishing in a day. Or if you were standing by a river and you looked at the amount of fish that were in a given area. So there's a qualifier to it. There's a time period, there's a size, there's a volume, an area. So if that helps you out, maybe. If not, if metaphors aren't your thing, I understand. This is a similar question about what type of distribution. So for this one, we're looking at a zoo, and they have 50 total guests that visit their tiger exhibit, and they notice that 35 of them are children, and 15 of them are adults. And they decide that they're going to pick 6 of them. And if I was curious about finding what's the probability that 4 out of those 6 were children, what kind of distribution would I be looking at? So hypergeometric, why?
They're only interviewing 6 guests. Zeus math decides to randomly interview 6 guests of the 50.
So we're taking we're sampling a subset, and we're asking about the composition of our sample. So that's one point. And when you're going through these problems and trying to decide which form to use, you can always start plugging your variables. He was talking about n's and r's and small n's, looking at how you define success, often what kind of random variable you're using. I would also like to mention I've seen a couple stats classes, and I don't think all stats classes necessarily cover these distributions, so some of you may be thinking, we didn't cover this at all. Like I said, if your professor didn't cover it, it's not going to be on your final. Other stats professors did cover this. Sorry. So here this is asking about characteristics of a binomial random variable. And notice in the problem it said what's not a characteristic. So which one did you guys come up with? So A, why is A wrong? How could we change A to make it right? So the trials are independent. So this is another thing where you just look at those characteristics. And this will help you, again, like the problems we were doing before, of ways to decide if you can use a certain type of distribution, when you use it. So just making yourself familiar with those characteristics so you're able to answer the types of questions like the ones we just did. This question sort of broke that down into details. Sorry. I will say for this question, the first question you should ask yourself is what kind of distribution I'm using, and then try and solve it. So for this problem, we're looking at a class that meets for 90 minutes, and any student who arrives between 1 minute late and 15 minutes late is marked tardy. But any student who arrives after the 15-minute mark is marked absent. So First of all, before we get to the actual question, what kind of distribution are we talking about? Go ahead. Sorry, what were you? So the probabilities of sort of like arrival. So. So if we're dealing with this fixed time period, it's 90 minutes long, what sort of distribution are we looking at? So if we're looking at, so the class runs from minute 0 to minute 90. And the students can arrive anywhere in there. So I heard uniform. So sort of when you look at that shape. So then what does the formula look like for the uniform to find the standard deviation? Real quick, for the people who do have Dr. Jurassic, I would refer to the warranty and car example specifically for this type of problem. I thought that was a really good example. So this example's kind of worked a similar way. Yeah?
Question. Are we saying, Christine, from the probability for students to show up into the class is the same the entire 90 minutes of their class?
So essentially, that they're just as likely to sort of show up on time as they are like halfway through.
Wouldn't it be more likely to show up in every 15 minutes so that they can be marked faster? Marked starting.
Could be.
Then have to make the assumption that's you.
That's true. I probably should have added like a little tail end there. So I was just going towards more that there was a fixed, it's 90 minutes, you're only looking at a certain time frame. There is no all values. So this is the one probability distribution that we were looking in a very slim margin of values, that nothing exists outside of it. Because you can't come to class technically before it starts. There's no class being held before the 0 minute mark, and there's no class being held after. So it's sort of looking on the time, but you made a good point. Your professor will probably then specify uniformly distributed. So if we're using the uniform distribution, find the standard deviation. So what do we put for D and what do we put for C? So we have 90 for D minus 0 for C. And then over the square root of 12. What number did you guys get for that? Approximately, because the root makes the number look strange. 26, so C. So this was just a matter of knowing what to use to find standard deviation. And again, your professor, there's a good chance they might tell you it's distributed a certain way, because this one, there's not a lot of detail to this problem with the uniform distribution. So if we're looking at a uniform distribution, how do we compute probabilities? Since this is just attached, I'm going to transition right into it. So if we're working with a uniform distribution and we want to find a probability, oh, if you want a little more of the problem, sorry. So what's our formula for probability for a uniform distribution? So B minus A over D minus C. What does this look like specifically? Because it's the probability of them being marked tardy. So in what range is that? For what range did they say they're marked tardy? So 1 to 15. So we already mentioned what D and C is. What's B and A, respectively? So what's B? So 15, then A is 1. So over here it's in the form of A, X, B. Again, sorry if I can't hear you. This is a very big space. So if you've spoken, I didn't hear you, I'm sorry. So what would you get if you calculate that out? So B, 0.16. So now we're going to start getting into the stuff maybe everyone's familiar with. So here we're dealing with a weighted coin. So normally a coin has a 50-50. This one's not a fair coin. You may hear of like unfair dice. So here the probability of heads is 60%, and we flip that coin 10 times. And I ask the probability that we're going to get more than 6 tails. What kind of distribution or way of solving are we looking at? What kind of problem? So a tree diagram. So, but what's sort of like the name of what we're looking at based on like the outcomes, probability? Speak up. So I heard binomial. So when we look at the word binomial, so 2 categories. So for when you flip a coin, you can have heads or tails. So we ask about the probability of getting more than 6 tails. So we want the probability that we're going to get more than 6. So how do we go about solving this? I will say there's 2 ways. One's maybe a little simpler. I see some people are getting out their tables. It's probably a good lead. And we just happen to have a binomial table. So again, if you have a different professor, your binomial tables may look a little different. Sorry, different professors print different tables. Hopefully the theory is all the same. So I can see that we have 3 values we need to be able to utilize this table. We have a p, a k, and an n. So for this problem, what's our n? So I heard 10, so the number of times we're flipping it. What's our p? So 0.4. Why is it 0.4 and not 0.6? Because we want tails, and the 0.6 refers to the heads. And what value of k are we going to be looking up here? So I heard 6. So we can go to our n equals 10. And go to our p, go to 0.4. I'm going to try and zoom in a little bit on this. Okay? Should have your tables in front of you. 0.4. We said our k was 6. So if we go across, we get 0.945. What do we do with that number? Are we done? What does the table give us? What value? Does it give us the probability x is greater than k? So I heard no. So how do we find this probability of x greater than k using the value we got from our table? Sorry, let me zoom this out. So if it doesn't give us x is greater than k, what does the table give us? So I heard less. Does it include k? Or not include k? Are we dealing with a less than or equal to, or just a less than? So if you look at your table, it does mention whether it includes k or not, if you can sort of remember your summation notation from algebra. So does the table value include k or not? So that's less than. Is it less than or equal to? So equal to. So what our table gave us, the probability of x is less than or equal to 6, and it gave us 0.945. But we want the probability that's greater than. So what do we do? So I heard 1 minus. Why do we use 1? This goes back to the the main rule of probability, essentially. One of the 3 big ones.
Max probability can only be one.
So the max probability, so the sum of everything. So the sum of all our values, so we're saying this is all less than and everything greater than. So we take everything that's on one side plus the other, it should equal to 1. So we do 1 minus 0.945, and I got 0.055. Did anyone else get anything different? I always like to check my math with you guys. Okay. So here's more of a conceptual question. I'll move it up a little bit. In the interest of time, I might start giving you guys a little less time on questions, especially with this where it's conceptual. Okay, so when we're dealing with a standard normal distribution, what is the mean and what is the standard deviation? So which answer option did you guys find? So D. So the mean is 0 and the standard deviation is 1. Pretend that's normal shaped. So our mean 0, and on either end our standard deviations are 1. So now Z-scores. So probably the thing that pops up most. If you're just coming in for statistics, that's cool, feel free to jump in, or if you're just coming in for studying, just keep in mind there's a session going on, so. So for here, we were looking at the probability of our z-score being less than 1.4. So what did you guys find? If this is something maybe you forgot or you don't like the way your answer looks, try drawing it. Graphically, knowing how to understand it graphically, that will help you a lot in this course. If you have time on the test, it's a great way to check yourself. So what did you guys find? And let me know if it's something that isn't like an answer option as well. So I heard D. So we can graph it. So what is our mean going to be for a curve like this? What's our center? So we just talked about 0. So is that 1.4 to the right or left? So the right. So we said before when we're talking about skew, usually going right, you're going positive. Left is you're going negative. So we asked for less than 1.4. So all the area in here. So when we're looking at, so how do we find that area? So you see people lifting up their tables. So we can flip to the appropriate table. We grab our z-score. So when we look up 1.4, however, we get 0.4192. So why is the answer 0.9192? So we have to add the 50 over here. So that 0.4152 corresponds to just this piece. And then we add it with this 0.5 to the left. So as we mentioned, it's a symmetric curve with the normal, it's standard, so the mean is 0, so we have everything to the left is 0, everything to the right is 0. So we have, and we mentioned before that everything equals 1, so we can split it right in half. So 1/2 will be 0.5 and the other half will be 0.5. Go ahead and try this one. The key to these problems is just setting them up. So for this one, what answer did you guys get? So A. So when we look at it, we mentioned that with our center of 0, negative value would be over here, positive value over here. We said the area between. And just like up here when we said it gave us the area between 0 and the value, we have one piece over here that'll give us part of it, and another piece over here will give us another part of it. And when you solve both of them, you should get 0.7705. And now one question doing it backwards. Perhaps. Well, not so much backwards, it's working, instead of working for probabilities, but working with x values. So, did someone already answer it? I heard, no, that's fine. Hey, you got it. So I heard B. So with this one, we're given a mean up here. Personally, I just find it's always useful to write out my variables. Standard deviation of 2.6. And this time, we're given the z-score, and we want to know the weight. How do we set up this formula? And then when we're finding x, we can do a very quick algebraic rearrangement. Move the standard deviation over to this side. Then add the mean over. And when we solve for that, puts out b. So we already said which each of these variables are. We have them. Plug them in. Make sure you watch the sign on z. So here it was just 1.78. It's positive, not negative. So give you 18.628. If anyone got something different from that number, let me know. It is a rounding, so if you're a little, like a tenth place off or something, you're probably fine. So here, since we already did a couple of z-scores, I'm going to skip this one. But like I said, I'll give you a link later where to find this, and you can try this one. Just in the interest of time. So, quick conceptual question. So instead of giving you guys problem-solving time, we'll just talk about it. So, I asked you about a parameter versus a statistic, sort of comparing them. So which of these statements is most correct, we'll say? So B, so a parameter is a measure of the population, and a statistic deals with the sample. They make it really easy for you because you can just watch the P's. Parameter, population, statistic, sample. That's just a way to remember it if you get it backwards, but I mentioned this earlier, but keeping it straight, what deals with the sample, what deals with the population, will help you a lot when setting any of these problems up or when thinking about it conceptually. This is another term question. So we have a value that's the standard deviation of the sampling distribution. So moving on to sampling distributions right now. What's another term that probably is less of a mouthful that you may see written more often? So standard error. And again, that's something that if you missed it, go back and look at your textbook and your lecture notes. So like I said, now we're going to look at sampling distributions for a moment. So we're looking at the cost of tuition, and we said it's approximately normally distributed, and the average cost of a year's tuition in Florida is $11,750. So we have our mean, and our standard deviation is 2,600. So I'm going to sample 40 students from across the state at random. And I want to know the probability that of those 40 students, when I average their tuition cost, that it's less than 10,000. So what does that less than 10,000 represent? What variable? So x bar. So we want to know the probability that our x bar is less than 10,000. What does the 40 represent? What variable? So our n equals 40, our sample size. So what's our next step? Now that we've defined our variables and we know what probability we want to find, how do we go about finding it? So we're going to look at a z-score. So how do we calculate our z in this case? What does our formula look like? So the number of standard deviations, okay. So then what does the formula look like? Standard deviation divided by n, or square root of n? Keep track of that formula. So we notice it's a little different than our previous z-formula score, or z-score formula, sorry about that. Where now we have to include sample size when we're looking at the sampling distribution. So what value of z do you guys get when you plug this in? What value of z do you get? So did you say negative? Yes. So negative 4.26. So we converted this to a z, so now we're looking at the probability that our z-score is less than negative 4.26. What is that probability, approximately, for this one? So 0. So when we look at our table, it doesn't even come close to 4. So it has just gotten so small that it's something. But it's about 0. So if that is the true mean, you'd be hard-pressed to find 40 students that pay less than that a year. So here is a problem for you guys to try later, and it's doing the same calculation, but we're just shifting the n value down to 17. Again, I'll upload the key for this afterwards, so you can try that one. So now we're going to look at back to proportions and probability. So for this one, we're going to look at proportion rather than a mean. So problem says 65% of all UCF students have been to the campus Starbucks at least once. So you take a sample of just 150 of those students and you ask them, have they been to a Starbucks before? So what's the probability that more than 70% of the 150 students you ask have been to the Starbucks? So what does 65% represent? Through what variable or what that variable represents? Are you solving the problem or? Okay, I think you're ahead of most of the people in the room right now. So let's take a moment though and answer, what does the 0.65 represent in this problem? So the success probability. So what is the variable for that then? So before, well, in your class all term long, you probably looked at different types of p. So there's like a p and a p hat, p tilde. So which one of these is this? Is this just straight up p or is there a modifier? So why do you say p hat? So is 0.65 the sample? Or the population? So here the population. So what about p hat in this case? P hat is 150. And now here 0.7. So which is it? Or if the person who said that p hat was 0.7, what does the 150 represent? The sample size, so n. So I mentioned that the p's all have to deal with proportions. So then, how do we interpret p hat for this problem? So is it exactly 70%? Or because in this problem we're talking about mean, we mentioned that x bar was less than 10,000. So how about here? Is it p hat equals or something else? So we're looking for p hat greater than 0.7. These are sort of similar examples, just proportion and average. A little bit of a different methodology, way of thinking about it. So then, what's our next step? Where do we go next? Now that we've defined our variables. And we know what we want to find. So what are we calculating next? Think about what we did in the average example after we defined our variables. What's our next calculation? So I heard the z-score. What does the z-score formula look like for the proportion with sampling distributions? E hat minus P. Okay. Over N. Yeah, like I said, sorry. Sometimes it's hard to hear you. So we have N, we have P hat, and we have P. So what do you guys get for the Z when you plug this in? Just for plugging in the z-score. Point 1.28. Positive or negative? So positive, 70 greater than 65. So now we're looking for the probability now that a z is greater than 1.28. So when we graph it, mention that positives are over here, and we said greater than, so I want to the right, going more positive. And we mentioned that our z-table gives us this area. So what do? Find the probability we want. So what do? How do we set this up? So we do 0.5 minus that probability we get from our z-table. Brings back that rule of symmetry we were talking about earlier. Pull up our table. Go 1.2 over here. Skim over to the 0.08 column, so we get 1.28. We get 0.3997. And what do you get? So I think I heard 0.1003. Okay. I think when I was writing these answer options, I made a slight rounding error somewhere, which is strange. Probably when I rounded your z-score, I did something a little differently. But I will fix this on the key as far as the answer choices. You can see that it's really not here. There's this one that's kind of close, but a little off. Okay. So this is a conceptual question. you guys can revisit a little bit later when you're reviewing, just in the interest of time. So, but this is a nice conceptual question. And we're talking about confidence level. What variable represents it? So now we're going to start moving to hypothesis testing. So alpha, better recognized as the swimming fish, sideways Greek egg. Again, knowing what your variables mean so the formulas make sense. Okay, so time to construct a quick confidence interval. Okay, so we're going to construct a confidence interval with 95% confidence. So if we have 95% confidence, what's our alpha? For alpha? Sorry, I just couldn't hear. So, what's our alpha level? 0.05. Okay, so for this problem, a restaurant chain wants to know about the mean wait time for its guests that are waiting on their food. So they asked a bunch of people, a bunch of their customers, their diners, 330 of them, and they found that in that sample there was a mean wait time of 34.5 minutes and a standard deviation of 4.5 minutes. So we're going to create a confidence interval. So what formula do we use for constructing a confidence interval for a mean? What does that formula look like? So, what formula are we using? Can't really solve this problem without pulling up the formula, so. Z of what? Okay. So, quick question, do we know sigma? Or are we using an estimation? So, yes to are we using sigma, or yes to are we using an animation, or estimation. So her estimation. So Sometimes if we don't have the information available, we use a slightly different form of the formula. What's x bar in this problem? So 34.5. What's z alpha over 2? Or 1.96. So for things like 90, 95%, 99%, those should be z values that you should, or z-score values that you should just know because you're going to use them a lot. Usually what you're using is that value. Depending on your professor, they may have you use weird ones, so know how to find it if it's not one of those main three. So what's our S value? And then our N. So 330. So when we do that math out, what interval do we get? Let me know what values you got. And you said 34.9. So that's what I got when I redid it. I feel like I did a weird rounding thing again when I wrote these answer choices. Again, I'm sorry. I'm a student, so sometimes when I'm writing out the answer options and resolving the problem, calculations may get a little strained. So just keep in mind your professor's writing the test. Probably going to check it a couple more times than I do. And again, I will fix these on the key. So before we mentioned that we didn't know sigma, so we could use S as a form of estimation for the population standard deviation. Is there another way to estimate it, or is that the only way? If we don't know sample standard deviation, we don't know the population standard deviation, is there another estimate we can use? So E, so only in A and B. So we can use the range over 4. So keep in mind you want the one that's sort of like the most accurate estimation. So if you want population standard deviation, if you have it, use it. And then just sort of rank it in order of what seems like the most accurate estimation. What does the variable Q represent? So why do you say C? Why is it not both B and C? So amending your answer. So then B is probability of failure. So we mentioned that P is probability of success. So then when we're dealing with P and Q, so P is probability of success, Q is the other side of the coin. we said that Q is 1 minus P, so both B and C. So because we're getting down to the end, we'll cover like a little bit of hypothesis testing, but really if you understand the basics of hypothesis testing and you understood building confidence intervals and you feel good with doing z-score calculations and t-score tabulations, which are a little different, then hypothesis testing is that application. It's where everything we've done throughout the semester culminates into hypothesis testing. So when do we decide to reject the null hypothesis? So A, when our P is less than alpha. Why is it not C? How can we change C to make it correct? So if Z was inside our rejection region, what about D? How can we amend that to make it correct? Sorry, I can hear someone's trying to say an answer, but I can't hear it. How could we change D dealing with t-scores? What's the rejection rule for t-scores? So we covered P level, we covered z-scores. What about t-scores? What do we change about answer D? All right, so I will leave that one for you guys to look up as far as how the T relates to the T critical value. It is something I think is important. It could be asked. So that's why it's probably important to know if your professor can ask it, try and know it. So here we're doing more sort of calculations with Z and T, and then being able to calculate things like p-values. We don't have time to go through all of my remaining problems, so I'm just sort of scanning through these and pointing out things that you guys can try at home with these hypothesis testing examples. Like I said, applying what we've gone over, this is just the application. If you understand rejection regions, you understand p-values and how to calculate them, how to relate them back to alpha, then hypothesis testing is just that application. So a quick thing, so for the rest of the problems, because there are 47 of them, you can, I will be posting it with a key. And for the students who have Dr. Jurassic, it is the website that is linked under my name on web courses. This is sort of like an external site. And then for those of you who aren't, you can grab all 37 problems and the updated key on this website. And one last thing that is super helpful for getting feedback for study union, and we would ultimately very much appreciate it, is you can take a survey that gives feedback on these sessions every time you attend a study union session, and this one, so you can scan this QR code You can either scan it from here or on the ends of your tables on either end. There is a QR code you can scan and take the survey on your phone. So you'll be able to let us know how things can improve. So other than that, I wish you guys the best of luck on your various exams, and thank you very much.